Hello viewers and welcome to a new STM32 World video. Now this video is probably going to be posted as a rant because it doesn't really qualify to be included in the regular tutorial video series, so I'll do another rant. It's okay, because I probably will express some opinions in this video. We'll see. A while back, I made a video on how to use SD cards with FATFS on them using SDIO. I also made a video on how to do it with SPI, but the SDIO video remains actually one of my more popular videos. It gets a lot of views, and I guess that's because this is actually fitly to make work. In reality, this is one of the few videos I was unable to shoot in one go. I actually finished the video and then I discovered I had been an idiot, and then I added a follow-up, the solution, a probably solution. Now, one of the issues that people are facing is that you can access SD cards in multiple ways. You can actually, on most cards, just use an SPI, a single SPI channel to access the card, but you can also use something called SDIO, which is a peripheral built into a lot of the STM32 MCUs. Now, in the original video, I actually used a board I made myself with an SD card slot on it, but just to demonstrate that this can actually be used, in this video I will be using an adapter I quickly hacked together, and there is a photo down here which I can show. It is simply one of those adapters, micro SD to SD adapters, where I have soldered a bunch of wires on it, test leads on it, and that is it. That's not ideal, of course, but well, as you can see in this video, it actually does work. Another thing I will mention before we are going on in this video is that SD cards are quite different. You can't just find one SD card and that will work for everything. So in this video I will be using the same one I used in the original video, which is Kingston Canvas Select Plus 64 gigabyte. It works fine. Whether this one is an original or it's a clone, or I have no idea. I live in Malaysia actually, and 90% of the stuff you buy is probably copies out of China. I don't care. This one works. It's as simple as that. Now, one of the issues that I came across in the original video, there are multiple issues. First of all, I think what catches a lot of people is that SDIO require pull-up on 5 of the signals. In my own card, which I used originally, I have those pull-up resistors on the board, but if you do it with an adapter like I do today, you will need to enable those pull-up resistors. One of the issues is if you initialize in 1-bit mode, this is the code, how it looks. It works, but there is a bug in the STM32 HEL libraries or STM32 CubeMX, which catches a lot of people out. In fact, the very reason I do this video is that the comments on this original video, there are some really interesting one, particularly the one from Viki9621, who's quite insistent that 4-bit mode simply doesn't work. And in his last comment, he actually did challenge me to prove that it was working. So consider this video my proof that this is, I was pointing at myself, I'm on another screen, so, but there. It does indeed work. So what I have done here is I have gone to where are we here. I have gone to my original example. All these examples are on the STM32 fun repository on GitHub, so you can just go and get them there. I have taken this one, the original one that I actually used in the process, and I have made one change in this one. For now, I have gone down SDIO, I have switched that to 1-bit mode. So this is 1-bit word mode, and that should more or less always work. If we look at the initialization down here, we actually don't need that line. So it basically, these are all set by the STM32 cube ID, and I initialize the SD card. If you don't initialize it, it will be initialized by FATFS once you start that up. So it is technically, in this situation, not necessary to initialize the SD card. But anyway, let's look at what I'm actually doing in this, the relevant part of what I'm doing in this code. During the beginning, I go up, where is it? The big file name here. So I open one called big file name, which is big.dat, and I dump buffer is 1 kilobyte, and I dump 1024 of those. So in other words, I write 1 megabyte into this file, and I do it in chunks of 1 kilobyte. I simply keep dumping that buffer down, and I measure the time in milliseconds that it took, and I write out how long it took to write this file. Now down in the main loop, every 10 seconds, I believe it is, 10,000 milliseconds. Every 10 seconds, I will open that file. I'll read into a same 1 kilobyte buffer until the file has been completely read, and then I'll print out how long it took to read this file. In fact, for now, let me remove that, because that actually just confuses the output. Let's try to run this and see what is happening. I will need to remove my face to make that done there, and let's look at the output here. So you see, it starts, it prints the SD card information, and then it writes that megabyte down, and that took 1.265 seconds, or 1265 milliseconds. Remember that number. And then you can see every 10 seconds it will read that megabyte, and that takes 879 milliseconds, or 0.879 seconds. So that is it. That is running in 1-bit mode. Now let's try to switch this to 4-bit mode. So there are a few things that needs to be done. First of all, let's go in here and we simply switch it to the 4-bit wide bus. One thing, I didn't mention this. I didn't mention this earlier. The data lines need to be pulled up. So if we now go into GPIO settings here, you can see that they don't have the pull up, only the 01 have, and that needs to be changed to make it work on without actual physical pull up resistors. So we need to go in here, and we need to enable the pull up on that line, that is, and on data 1, and on data 3 pull up. We need it on the command line as well. We do not need it on the clock, nor do we want it on the clock. So the clock line is the only one we do not have a pull up resistor for. So that is about all the changes that are needed inside STM32 Cube MX. So let's try to generate the code. Now, this will not work, and I am baffled, and this is why this is a rant. I don't understand why ST has not fixed this. This has been reported and discussed for at least 4 or 5 years. There's a lot of old posts that are desperate, and I mean, it would be easy to fix. Now, the problem that they are doing, the biggest problem anyway, is down here in the initialization code. If you put the 4-bit mode here, this will fail. It'll be hanging here because you cannot initialize an SD card in 4-bit mode. You have to use 1-bit mode and then tell the SD card switch to 4-bit mode, and that will work. So the solution I came up with is, okay, I don't want to edit this block because that will be overwritten by STM32 Cube MX every time I update, but in this user section down below, I simply set that to 1-bit mode before I call hell init, and that works. Then, after we done this, we can switch the white bus operation. We SD card, we switch it to white bus operation and set it to 4-bit, and that will work as well. So let's try to compile this and run it and look at the output here. So now write took 700 milliseconds. Before it was 1.2 or something like that, 1.3. So almost double the speed, and read only takes 343. I think it was 700 something before. So it is almost double speed. It is not 4 times speed, and that is most likely because the bottleneck on these SD cards, where are we? The bottleneck is probably the physically flash read-write inside the card, so it is entirely acceptable, and I wouldn't expect a 4 times speed increase, but it is in this case at least a doubling of the speed. Now, one final thing I want to mention, if I go in here, wait, I want to talk about, I don't have an answer to this, and I am actually a little bit embarrassed, but in here you have an SDIO clock divide factor, which is 2. I have set this to 2. I believe this card will actually run, let me try it with 1, generate code. I think it will still work, but it might not. Let's check. Oh, there, we flash. Let's look at the output. Oh, I did already. There. 670. It didn't become much quicker, did it? What was it before? 700. Okay, it did become a little bit faster. And now I can read in 300 milliseconds. But the reason I mentioned this is I was trying with another SD card, a 32 gigabyte SD card earlier, and it failed with 1. So, I mean, this value here is a little bit fiddly. I think what we are talking about here is, if we look over, I honestly don't know where the SDIO is clocked from. I don't know, but if it hangs off of APB2, then it would actually run 84 megahertz peripheral clock. Let's look at that actually. Oh, no, never mind. Let's actually look at it. I like to know what I'm doing, so let's look at the where are we? The official documentation here, and we go down to STM32 and look at the datasheet and find the block diagram. That's usually the quickest, which is coming up there. Need to zoom that in a bit to actually see what is going on. Here we go. So where is it? I'm sure you're all screaming. It's there, right in front of you. There. So it is hanging off of SPI1 and SDIO. It is hanging off of the APB2. So in other words, APB2 is clocked by 84 megahertz. I read somewhere, I have not gone through the SD card standard, but the original SD card standard, as far as I know, 50 megahertz was the absolute max, which can explain why this needs a divide factor of 2 to actually work. Now, as I said, this is extremely, it is fiddly to make this work, and I did spend quite a lot of time on it, but well, I also can show here, it is, here you have I'm running it on my STM32 World Development Board, and I have just hooked up, the SD card is hanging up here at the top, and that is all there is to it. So it can be brought to work, and it does. 4-bit mode does increase the speed, at least in certain cases. I would not rule out that there are SD cards that doesn't support it proper. I don't know, but it can be brought to work. I will still leave this video as a rant because I don't understand why ST doesn't fix this bug. It is, in my mind-boggling that you need to make a workaround like this to make their code work. If you leave this out, it will hang. The moment you fire up the FATFS, it will initialize the SD card, and it will initialize the SD card. It will attempt to initialize the SD card in 4-bit mode. It's as simple as that. It doesn't work. So this little workaround, by putting it down in the user code, it does not get overwritten, initialize in 1 bit and then switch to 4-bit mode. That works, and it works pretty much every time, with the 2 caveats that I mentioned. You need the pull-up resistors on those lines, otherwise it's hanging, it doesn't work. And you need to make sure your clock speed is within the tolerances of whatever SD card you're using. Probably if you want this to work with all SD cards, I wouldn't rule out you need to go up to 4 or 3 or something like that. I wouldn't rule it out. I have not tried. Well, you can go back and look at my video. I'm quite sure in my original, you have it out here, the SD, where is the SPI version, which is there. I'm quite sure that that works with full speed SPI, which can never go beyond 50 megahertz, I think, on an STM32. Anyway, so that's about it, my rant for today. And what was his name again? I think Mr. Vigi 9621 has been proven wrong. QED. Bye bye. And as usual, have a wonderful rest of the day.